Hi, good to have you back. This video is about how to build a recommendation engine pipeline with BigQuery ML and Vertex AI pipelines using matrix factorization. It also includes the automatic handling of the slot reservations to keep the costs at a minimum, and we take the model and deploy to Cloud Run to make online recommendations. Matrix factorizations are widely used for recommendation systems. They are a great and easy starting point if you want to quickly build an easy solution to deliver great recommendations to your customers. It took me around 45 minutes to implement the code for this video. So even the smallest teams can implement those types of simple recommendation systems, at least with the rich capabilities of BigQuery ML and Vertex AI. So let us switch over to the code. Our pipeline is responsible for the whole recommendation process, including managing the BigQuery slots and deploying the model to get online recommendations. So here you can see how the pipeline looks, and it actually has a couple of steps. First, we have to create a slot commitment, the reservation, and the assignment. Then we actually have to build a BigQuery matrix factorization model. And after that, we immediately delete the commitment, the reservations, and the assignments again. Then we export our model to a Google Cloud Storage location. And finally, we take our model and deploy it to Cloud Run to make it available for online recommendations. So let's jump over to the code. The first thing, like always, we have to authenticate the notebook in order to be able to communicate with Google Cloud Platform. So I did this already. Usually opens up a pop-up, select your Google account, that's it. Then we have to install the dependencies for AI platform and for Q4 pipelines. And we also use a couple of pre-built components. We need to install them as well. So we do this. I did it already. It's just checking the dependencies. It's done. Next step, we have to restart the runtime to make sure we actually use the latest dependencies we just installed. So it's now restarting. And we are ready to import our required dependencies. If you're totally new to matrix factorization, there are also 2 articles in the video description below. Step-by-step guides on how you can actually implement this kind of stuff without pipeline, just the BigQuery parts of it. So I can highly recommend it if you're totally new. And except for that, the data I use is as always the movie lens dataset. So if you want to get the data to reproduce this example code, just go to the documentation link and download the data and import it to BigQuery, and then you can get right started. So let's start with our first component, the capacity management, slot management that we needed in order to be able to do the matrix factorization. So slots are needed to build those kind of matrix factorization models. Usually with BigQuery, we are built by the amount of data we are processing. And with BigQuery ML matrix factorizations, we use alternative least square for explicit feedback and weighted alternative least square for implicit feedback. Both ALS and WALS require many iterations over the data. And since recommendation datasets can get quite large and we need a lot of iterations, this would be just too expensive, and that's why Google decided they introduce another building here. So we need to use slots, and for slots we need to make reservations. The reservations, the slots we're going to use in this example are flex reservations, flex slots. So we only have to commit to a minimum of 60 seconds. So there is no need to commit to 1 month or years of commitment. It's just 60 seconds, and after that we immediately can cancel. That's why we reserve our slots, we do our matrix factorization, and then we immediately can delete them again. In this way, we only pay for the slots needed to actually build our matrix factorization model. So the first component is our component which creates the reservations of our slots and the commitments. Before we dig into the code, we head over to BigQuery and see how we can actually do it in UI before we do it via API. So on the left side of the BigQuery navigation tab, you see capacity management. And here we can buy slots and create reservations. So in our use case, we want to buy slots. The commitment duration, we choose flex, so we can cancel it at any time after 60 seconds. Allocation US, wherever you want to execute your BigQuery stuff. So I keep US. And number of slots, 100 is minimum, as far as I remember. And this is sufficient enough for our use case. So we take 100 slots. And then we have to confirm the purchase, because it can get quite costly, as you see. If we keep this reservation for the whole month, we pay approximately $3,000, but we don't need it for the whole month. We only need it when we build our model. This takes approximately maybe 4 or 5 minutes. So it's just a few cents we actually pay for these reservations. Don't worry about this. We cancel them immediately after the model is trained. So we purchase the reservations now, the slots. Takes a couple of seconds. And now you can see your purchase request has been submitted. And we will see, usually they are immediately available, so they are already here. And now we have to create a reservation. Reservation name, I call it matrix factorization. Same location, number of slots 100, because that's what we have. So you see 100 unallocated slots. And we want to allocate all of the hundreds we just bought. So we save this. And now we have a reservation here of our 100 slots. And now we have to create an assignment to this specific project. So I go here. And here I go to Sasha Playground Do It. This is the project I'm currently in. And in this project, I want to have the reservations. And now we are ready to go to build our model. And after that, we automatically remove the reservations again. This is something we also do now in the UI at least once. So we go here, delete our assignment, then we delete our reservation, and we go to the slots, and we also delete our slots. Now the slots are gone. And this is exactly what we now gonna fully automate as part of the pipeline. So back to the code, and we have a deeper look into it. The first thing you see, we have to install a dependency, which takes care of communicating with the API, with the BigQuery reservations API, or just a Python SDK. And then you exactly see what we just did in the UI. We have our capacity commitment, we have our reservation, our assignment, and we have a client in order to communicate with the API. And you also see the 3 steps here. It's pretty straightforward. We want to have a flex capacity commitment with the number of slots. That's the first step we do. And we create a capacity commitment with the client. Note the commitment name. We need the commitment name later on to cancel the commitments and delete the commitments again. Same for reservations. We say 100 reservations. We put it here as parameter. Again, create reservations. We also have to keep the reservation name to delete it later. Same for assignment. What we're executing is a query. So we take as job type query, and we define a project where we want to have this assigned to. And we also keep the assignment name because we also, you see it here at the end, we return it to give it as input for the component, which takes care of deleting all the stuff. And important one, we have to sleep at least 2 minutes because it takes, maybe sometimes it takes a minute to actually, until the slots are available. So if we would immediately start our model training, it would fail. So we sleep here for 2 minutes. This is usually sufficient enough. The next component, not necessarily the next component in the pipeline execution, but the next component we implement here is the component which takes care of deleting the reservation, the capacity commitment, and the assignment. And it's pretty straightforward, just 3 API calls, and we as input for this component, you see we have exactly the same which we have as output from the last component. We just covered on how we can create our slots and delete them, and the next step is we have to actually build our matrix factorization model. So we go down to the pipeline because we use a pre-built component. It's here down in the pipeline. And you can see we have a component which is called BigQuery create model job operation. It takes in a query and it builds the model. In our use case, we build a matrix factorization model, and we have the input column for the user ID and the item ID, as well as the rating and the feedback type. So is it explicit or implicit? It's just a SQL command on how you can actually build this matrix factorization models, and it's input for this pre-built component. And you can see we execute this pipeline step only after the reservation of the slots is done. Otherwise, it would anyway fail. The next step after the model is built, we want to export it to a Google Cloud Storage location. The model is exported as a TensorFlow model. I think it's currently version 1.15. Just you need to know when you later on, when you want to deploy it, you need to know which TensorFlow version we're running on. And after this step runs after the BigQuery model is created. And as you can see here, we also have our delete reservation task we just covered. And this one is executed immediately after the model training is done, because we only need the slot reservations for the training and for nothing else. So we execute this step immediately after the BigQuery training. Since our last job exported the model to a Google Cloud Storage location, we now can take this model and deploy it. I decided to deploy it to Cloud Run. You could also deploy it to a Vertex AI endpoint, but in this use case, the model is quite small and it's sufficient enough to deploy to Cloud Run, especially because we can downscale to 0. So if we don't want to make any recommendations, we don't have to pay anything, which is quite convenient. The actual component to take care of deploying of the models is at first a little bit confusing, but actually still pretty easy. What we are doing, we use Cloud Build to build our Docker container. The Docker container contains our machine learning model, our matrix factorization model, and it's running a TensorFlow surfing environment. So since we anyway have a TensorFlow model, we just can surf it by using TensorFlow surfing. And this is what this deployment step is doing. We use Cloud Build, and the first step is actually downloading our model artifact, our TensorFlow model, to the Cloud Build environment so we can inject it into our Docker image. Then we build our, we also copy our Docker file, and then we actually build our Docker image and we push it to the Google Container Registry. And as a last step, we deploy our Docker image to Google Cloud Run, where we get an endpoint where we actually can get the recommendations. One step needed, as you can see, we copy here a Docker file because we need the Docker file to actually build our Docker container as part of the Google Cloud Build environment. So we have to copy it to the local Cloud Build environment. And if we scroll down at the very end, you can see the Docker file. You just need to upload it to Google Cloud Storage location. And here you see we have a space image TensorFlow surfing. So we just simply use TensorFlow surfing and we embed our module as part of the Docker container. So we can copy that as well. And the TensorFlow model server will pick it up and just serves the TensorFlow model. So pretty easy. Let us execute the pipeline and see how everything works together. So we go up and we compile our pipeline. And then we execute the pipeline. Now we go back to Vertex AI. And on the left side, you can see the pipelines. And here the pipeline is already running, just started. And if we have a look into it, you see the pipeline. And the very first component is the creation of the reservation. So if we now head over to BigQuery and we go to capacity management, and soon the slots should appear here. Sometimes it takes a few minutes until the component is executed. There it is. We have our 100 slots. And if we go back to the pipeline, we soon should see that we go to the next step. And here we have it. Now the second component starts running. We're creating the model, and this takes approximately 80 minutes. So I pause here and for you just a few seconds, and then we are back. So the training of the BigQuery model is done, and you can see it here. And now the next step starts, the evaluation and the model export. But before we check those two, we have some time to actually check the model. So we go into the SQL workspace of BigQuery. Open up the dataset, recommendation. And there we have our model, which we just trained. And in a few seconds, we also get the model exported to, it's already done, to Google Cloud Storage. So we can head over to Google Cloud Storage, and there we should also have our BigQuery model in a TensorFlow format. So this is great. The last step of the pipelines are now evaluation, which is also done. And you can see the reservations now getting deleted, so they should disappear soon as well. I can also quickly check the evaluation of the model by going to the artifacts of our evaluation step. And the artifacts are not directly displayed here because they are stored as a JSON file, so we have to go into the model lineage. And here we can view artifact in JSON, and here we get our evaluation metrics as a JSON. So this is also working. Back to the pipeline. And we see that now the deployment started and the reservations are getting deleted, and this should be also done in a few minutes. So the deployment and the deletion of the reservation is also done. So the first thing we do, we check if actually our slots are not available anymore. So we go back to the capacity management, and indeed the slots disappeared. And the last step was the deployment of our pipeline. So for that, we go to Cloud Build. And we see here is our Cloud Build process. And we also can see the steps. So first we download the model, then we download the Docker file to this local build environment. We build our Docker image, we push the Docker image to the container registry, and finally we deploy the Cloud One endpoint. And if we go to Cloud One, there should be a recommendation endpoint. Yeah, recommendations 1 minute ago. So this is this one. And here we have an API endpoint. So we can take this, go back to the notebook, and paste it here. Should be the same. And then we can execute it. The first request might take a little bit longer because we have a cold start of the Cloud One service. There it is. And now we have the recommendations for user with ID 25. We're getting the movie IDs back and also the predicted rating. Everything you need to actually use it in production. I hope you enjoyed this video. Subscribe, leave your comments. See you next time. Bye.